January 1943, RAF Bassingbourn, England. The roar of B-17 engines rolled across the frozen fields of Cambridgeshire. Inside the hardstand areas, mechanics worked through clouds of their own breath, wiping frost from metal that felt more like glass than steel. The sky was clear, the kind of cruel winter blue that promised no warmth at all. At 30,000 feet, above the North Sea and into the heart of occupied Europe, that cold became a second enemy, invisible, patient, and merciless. Every mission began with the same ritual. Men layered wool and leather until they could hardly bend their knees. They joked that they looked like walking wardrobes, but beneath the laughter lived quiet fear. Each knew what the cold could do. They had seen fingers turn white and stay that way, eyes freeze behind oxygen masks, lips split and bleed until the microphone filled with static. The enemy below could be outflown. The cold above could not. The air temperature at altitude hovered near -60. When bombers climbed through cloud and turbulence, the slipstream tore at every seam. At gun ports, where plexiglass was thinner or absent entirely, the airflow screamed past at 200 miles per hour. In those positions, even the thickest gloves could not stop pain from turning to numbness. The gunners called it the creeping freeze, the slow tide that started in the fingertips and swallowed the body whole. In the early months of the air war, the United States Army Air Forces had underestimated that enemy. The Standard A-2 leather flight jacket, a symbol of the aviator's pride, could hold off the cold for only minutes. Below the waist, wool trousers and boots designed for temperate airfields did little more. The men who fought from those unpressurized bombers were not soldiers in the traditional sense. They were survivors fighting the atmosphere itself. In those days, frostbite claimed more men than enemy gunfire. Medical officers recorded scenes that bordered on the unthinkable. Waist gunners whose hands froze to their weapon grips. Navigators whose pencils shattered when they tried to write their coordinates. Flight surgeons in the briefing huts stood helpless as crew after crew returned from missions unable to walk, their legs too stiff to bend. The official reports listed casualties not from combat, but from exposure. The 8th Air Force faced the possibility that the European winter would ground its bombers before the enemy ever could. It was then that Colonel Malcolm Grow, chief flight surgeon of the 8th Air Force, sounded the alarm. His November 1942 memorandum, now yellowed in archives, declared that frostbite casualties currently exceed combat losses. He warned that the strategic bombing campaign might collapse before spring. "We are losing the war to weather," he wrote. Those words, typed on a portable Army typewriter, carried farther than the sound of any bomber engine. They reached the highest offices in Washington and triggered an emergency that few outside the military ever heard about. An answer existed, though hidden in a laboratory corner. General Electric, years before the war, had built a handful of electrically heated suits for experimental high-altitude pilots. They were fragile, hand-stitched prototypes made from sheepskin and thread-like resistance wire. They worked briefly, but they were too delicate, too few, too expensive. When the Army revisited that design, it realized it had the seed of salvation. The decision came quickly. If American bombers were to keep flying through winter, every crew member would need what engineers called a self-heating garment. The order that followed dwarfed anything attempted before in protective clothing. The Air Force required 15,000 suits immediately and 50,000 a month by spring. The contract fell to General Electric's lamp division at Naila Park, Ohio, a factory known for light bulbs, not flight gear. Yet the nation's war machine could turn light into warmth as readily as it turned steel into bombers. Within weeks, design sketches transformed into prototypes. The new model, labeled the F-1A, resembled a two-piece flying overall lined with cotton-backed sheepskin. Beneath that surface ran 150 feet of resistance wire finer than a human hair. Each filament was coated in silk and asbestos to insulate it from the body and prevent short circuits. The pattern of wiring was no guesswork. Medical researchers mapped how blood circulated under cold stress and determined where heat mattered most. Chest and back first, limbs second, extremities last. The result was engineering tuned to physiology. Each suit plugged directly into the aircraft's 24-volt electrical system. A small control dial, the rheostat, let the wearer regulate the warmth, low when working hard, high when still in the turret. At full power, the system consumed 300 watts, enough to hold body temperature even when the world outside dropped below -60. In effect, The crewman carried his own climate with him into the stratosphere. But invention alone would not save lives. The challenge was scale. The suits had to move from drawings to production lines faster than any previous military garment. In January 1943, Nela Park retooled entirely. Light bulb assembly tables became workstations for cutting sheepskin. Conveyor belts once carrying glass now carried cloth. 3,000 new workers, many of them women recently trained in electronics, learned to solder the hair-thin wires that gave the suits life. Every connection required precision. Every circuit had to pass continuity tests with zero faults. Quality inspectors walked the aisles carrying voltmeters instead of clipboards. The pace was relentless. 14 labor hours went into each suit. The target was 6,000 suits per day by year's end. Mistakes meant more than lost time. They meant lost lives. The women of Nela Park knew that. Many pinned photographs of airmen on their sewing tables. They worked through the winter nights beneath the glow of the very lamps the plant had once produced, weaving heat into fabric that would soon ride with those men above the clouds. By March, the first shipments crossed the Atlantic. Wooden crates stamped electric suits, handle with care, arrived at depots in England. The flight surgeons who opened them felt as if they were unboxing a secret weapon. The F-1A suits looked bulky, almost primitive, but inside them lay the product of thousands of minds and hands aligned toward one goal: to beat the cold. The distribution began with bomber groups most affected by frostbite casualties. Technicians installed connection ports in aircraft cabins, running power lines from the 24-volt systems to sockets near each station. Briefings were held not about tactics, but about temperature settings. Crew members were warned not to overheat themselves or risk drawing too much current from the aircraft circuits. Still, the mood shifted. For the first time that winter, the men believed they might finish a mission without losing feeling in their limbs. In those same months, across the Channel, German air crews faced the same sky. But their commanders saw the cold differently. The Luftwaffe issued thick layers of wool and leather, adding bulk instead of technology. Their philosophy valued toughness over comfort, endurance over engineering. Their aircraft electrical systems, limited to 12 volts, could never power heated clothing even if they wanted to. German manuals of the time called cold a test of character. They viewed suffering as proof of discipline. The result was predictable: frozen hands, fogged instruments, and pilots who fought fatigue as much as the enemy. Meanwhile, the 8th Air Force prepared for its spring campaign with a new sense of readiness. For the men who climbed into the unpressurized fortresses of the sky, warmth was no longer a dream. It was stitched into their uniforms. On the morning of their first missions wearing the F-1A, they found themselves sweating slightly before takeoff, a feeling so alien that it provoked laughter. The cold still waited for them above the clouds, but for the first time, the battle would not be fought barehanded. As February gave way to March, frostbite statistics began to change. Where earlier missions had sent dozens of men to medical tents with frozen skin, now only a handful reported minor chills. Flight surgeons noted the transformation with disbelief. The war against the cold had turned, not with new weapons, but with wires and wool. Above Europe, contrails spread like pale scars across the sky. Inside those white trails, men who had once feared the cold now gripped their controls with steady hands. The bombers still faced flak, fighters, and the long hours home. But one burden, the most constant, the most merciless, had finally been lifted. And at Nela Park, Ohio, the machines kept running day and night, producing warmth for men who fought in the frozen heights. By April 1943, the first wave of electrically heated suits had reached every major bomber base in England. Inside briefing rooms, airmen stared at them like relics from the future. They were heavy, rough, and carried the faint smell of sheepskin and solder. Yet to those who understood the cold, they looked like salvation. Crews learned quickly how to connect the umbilical cord of warmth to the aircraft's electrical socket. A small dial by the hip became the most valuable control in the sky. The transformation was immediate and measurable. Within a single month, frostbite cases across the 8th Air Force dropped by nearly 90%. Missions that once left dozens of men hospitalized now ended with barely a handful needing treatment. Flight surgeons recorded their astonishment in terse medical language. Severe cold injury incidents reduced to negligible levels. But the meaning went deeper than any statistic. For the first time in months, crews stepped from their aircraft not crippled by cold but smiling. Warmth changed more than bodies. it changed minds. Fear of freezing had been a silent weight inside every man who climbed into a bomber. The dread of pain that crept through the gloves, the memory of skin splitting open, the awareness that altitude itself could kill, all of it sapped courage before the first enemy gun flashed. With the new suits, that terror began to fade. Men no longer dreaded the air they breathed. They could focus again on the mission. The heated suit did not make them invincible, but it gave them back control. Letters home began to mention the difference. A ball turret gunner described how he could now track enemy fighters for hours without his fingers locking. A navigator wrote that his pencil no longer shattered when he marked target coordinates. Even the pilots noticed it: smoother control, steadier hands, sharper attention in the long cold hours above Europe. The human element of warfare, alertness, coordination, morale, was being rewritten by a handful of resistance wires. At the same time, engineers in America were already improving the design. The F-2 model reinforced fragile joints, protecting the wiring from breakage at the knees and elbows. The F-3 added redundant circuits so that a snapped wire no longer meant freezing in the sky. Each iteration reflected lessons from returning crews. Gunners needed more heat in the arms and hands, pilots in the lower back and shoulders, bombardiers in the chest and forearms where they leaned forward over cold metal sights. Every role had its own microclimate, its own pattern of warmth. Supporting gear followed. Heated gloves, connected by small bayonet plugs, allowed dexterity without frostbite. Electrically warmed boots replaced the wool-lined footwear that had failed so many times before. Face masks joined the system late in 1943, turning the airmen into self-contained networks of electrical protection. Each item drew power from the same 24-volt circuit, controlled by a simple rheostat that could shift heat from minimal to maximum with a twist of the thumb. The production miracle behind it all had grown into a nationwide enterprise. General Electric still led the effort from Ohio, but dozens of subcontractors joined. American Steel and Wire in Cleveland supplied the nickel-chromium strands that glowed unseen inside the fabric. DuPont provided the insulating silk and asbestos threads. Pacific Mills shipped the treated sheepskin that formed the outer layer. Every factory worked under the same discipline that defined the aircraft industry: precision, repetition, reliability. By May, 2,000 suits rolled off assembly lines each day. By December, 6,000. The cost per suit, once an obstacle, plummeted with experience. What had started as a $250 experimental garment now cost $45. In a war where training one replacement crewman cost $40,000, the economics were obvious. Each heated suit not only saved lives, but saved the Treasury millions. In reports to Washington, procurement officers called it one of the most efficient expenditures of the war. Across the Atlantic, the results were visible even to the enemy. German fighter pilots, climbing through the thin air to intercept bomber formations, struggled with frozen fingers and fogged goggles. Their cockpits were smaller, their flights shorter, but the cold seeped in all the same. At 25,000 feet, the air in a Messerschmitt or Focke-Wulf could reach -40. Thick fur-lined clothing offered some protection, but movement was clumsy, reaction slower. The Luftwaffe's belief that hardship built character had become a liability. Comfort, it turned out, was combat power. American crews, warm and alert, flew higher, stayed longer, and fought more precisely. During the brutal Berlin campaign of winter 1943-44, temperatures outside the bombers averaged -52 degrees. Yet frostbite casualties averaged barely 2%. Without the heated suits, projections had warned of 30 to 40%. The difference was thousands of men kept on duty rather than in hospital beds. Major General James Doolittle later wrote that the suits contributed more to operational readiness than any single innovation except the bomb site itself. In mission debriefings, officers noticed the same thing: fewer errors, steadier shooting, sharper navigation. Warmth had restored accuracy as well as endurance. Even the long return flights across the channel, hours of vibration and monotony, became endurable. Crew members could sit still without pain gnawing at their joints. Behind the front lines, another quiet army worked to keep that miracle alive. At every major base, maintenance depots sprang up dedicated solely to the electrical suits. After each mission, technicians tested every wire and connector. They replaced frayed filaments, resoldered joints, verified that the resistance measured within exact tolerances. Most of these specialists were women recruited from civilian electrical shops, hands trained in wiring radios and lighting systems. To them, each repaired suit was as critical as a loaded gun. Cold kills as surely as flak, one technician would later recall. They knew a single broken wire could cost a life. The numbers behind the effort were staggering. The repair depot at Bassingbourn processed nearly 200 suits a day. Across the 8th Air Force, thousands more passed through inspection benches weekly. Spools of resistance wire, connectors, and rheostat parts filled storerooms as essential supplies. By mid-1944, maintenance of heated flight gear had become a permanent branch of the logistics system. The technology spread beyond Europe. In the Pacific, high-altitude missions over Japan presented different challenges. Less severe cold, but longer hours. The B-29 crews flying from the Marianas found that even with partial pressurization, depressurization failures could expose them to sub-zero air. The same suits, modified with lighter materials for tropical bases, served them as backup life preservers against the thin stratosphere. 50,000 were ordered in less than a year. In December 1943, fate gave the Germans a glimpse of what they lacked. A damaged B-17 made a forced landing in occupied Holland, its crew captured before they could destroy the aircraft. Among the spoils were several intact F-2 heated suits. The Luftwaffe shipped them to a testing facility for analysis. German engineers marveled at the workmanship, tracing every wire path and measuring each component. They admired the efficiency, the balance between weight and power. But in their final report, they admitted defeat. Their 12-volt systems could not support the current. Their factories lacked the nickel-chrome wire, the silk insulation, the quality sheepskin. And perhaps most critically, their doctrine had never valued comfort as a weapon. They concluded that the American suit represented typical enemy mentality, solving a problem through material means rather than spirit. Yet that mentality, the belief that technology should protect the soldier, not test him, was precisely what kept American airmen alive. By the spring of 1944, the effects of that philosophy were visible across the entire air war. Missions grew longer, altitudes higher, accuracy greater. The heated suit had become standard issue, as essential as an oxygen mask. The once lethal cold had been transformed into just another environmental hazard, managed, measured, and conquered by human ingenuity. Inside the bombers, the difference could be felt in the smallest details. The crackle of intercoms carried steady voices rather than shivering ones. The gunners' hands, no longer trembling, followed enemy fighters with precision. Pilots, once stiff with fatigue, could make fine adjustments on approach. The suits had not changed the weapons, nor the tactics, nor the courage of the crews. They had changed the conditions of survival. Outside, over the gray clouds of Europe, the temperature still plunged to -60. The air remained thin, the danger ever present. But within the aluminum shells of the flying fortresses, warmth now traveled through copper strands and woven seams, an unseen fire born in the factories of Ohio and carried across the Atlantic to the frozen heights of war. When spring came to Europe in 1944, the bombers still flew high above the gray clouds, but the war within the cold had already been won. The electrically heated suit was no longer an experiment or privilege. It had become standard issue for every American air crew crossing into enemy airspace. In the same way that oxygen masks and flak vests were taken for granted, so too was warmth, a quiet certainty woven into every mission. Across the 8th and 15th Air Forces, frostbite had nearly vanished from casualty reports. What had once filled entire hospital tents with men whose hands could no longer move now appeared as a statistical footnote. Medical officers began referring to cold injuries only in retrospective studies. The airmen themselves hardly noticed the change. For them, the miracle had already been absorbed into routine. They simply dressed, plugged in, and climbed toward the thin blue line where the cold waited, and lost. The effect rippled far beyond the immediate comfort of the crews. It reshaped the tempo of the air war. Missions could be scheduled deeper into winter, at higher altitudes, with greater consistency. Aircraft no longer needed to descend early because of crew exhaustion or hypothermia. Navigation accuracy improved. Bomb runs steadied. The air campaign gained rhythm and endurance. In war, consistency becomes power, and the heated suit gave the Allies exactly that. But behind every statistic lay human endurance reclaimed. For the gunners, warmth meant dexterity, fingers that could still squeeze triggers and adjust sights. For navigators, it meant steady handwriting across cramped tables. For pilots, it meant calm hands on throttles that demanded precision. The technology did not change courage, but it preserved it long enough to matter. In quiet corners of airfields like Bassingbourn, Thorpe Abbotts, and Kimbolton, technicians continued their unseen work. They tested resistance wires with voltmeters, replaced frayed connectors, and checked continuity through thousands of seams. Many of them had never seen the sky at 30,000 feet, yet they carried the same discipline as the crews who flew there. Each repaired circuit meant a man who would come back whole. Each soldered joint was an invisible act of rescue. By the end of 1944, production of electrically heated flight gear had surpassed 450,000 full suits, hundreds of thousands of gloves, boots, and masks, and countless spare parts. The cost per unit continued to fall as efficiency rose. Every suit that left an American factory carried the imprint of thousands of hands, each part of a chain that stretched from factory floors to bomber turrets, from seamstresses to flight engineers, from the warmth of Ohio workshops to the frozen edges of Europe. In the Pacific, new versions adapted to tropical airfields. They used lighter materials that would not suffocate crews during pre-flight preparations in 90-degree heat. But once the B-29s climbed into the jet stream above Japan, the same invisible heat followed them. The technology that had saved the 8th Air Force now crossed oceans, adapted to new altitudes, and faced new horizons. The Germans, for their part, never recovered from their early neglect of the problem. Captured Luftwaffe reports from 1945 revealed a mix of admiration and frustration. Engineers at test facilities had disassembled American suits, documented every measurement, even calculated power consumption with precision. Yet their final conclusion remained unchanged. The design was brilliant, but impossible to reproduce under their constraints. Their 12-volt systems lacked capacity. Their raw materials were exhausted. Their ideology had blinded them to the practical. One line from their final report summarized the failure. The enemy fights discomfort with machines. We fight it with will. But will alone could not warm frozen blood. As the Reich collapsed under relentless bombing, German pilots looked up at American formations holding tight, flying steady, engines humming in unison. Those bombers did not just carry explosives, they carried warmth, a warmth born of industrial power and empathy for the men inside. In a sense, every glowing filament of resistance wire represented something larger. A culture that believed a soldier's comfort was not weakness but strength. After the war, the technology found new lives. The same resistance wire systems inspired electric blankets for homes, heated car seats for motorists, and insulated clothing for construction and rescue crews. The idea that had kept pilots alive at altitude now kept civilians warm in their beds and cars. Hospitals adopted electrical heating pads for patients recovering from shock or hypothermia. Surgeons began using temperature-controlled blankets to stabilize patients during long operations. Even space exploration would borrow the concept. The first NASA engineers studying the thermal balance of space suits began with military documents from 1943. The heating elements that kept Apollo astronauts alive on the moon trace their lineage directly to the bomber suits of World War II. The scientific legacy ran deeper. Medical research on blood circulation, heat loss, and oxygen use at altitude advanced human understanding of how the body reacts under extreme cold. Flight surgeons who once battled frostbite now wrote papers that became the foundation of modern hypothermia treatment. The lessons of those winters over Europe would eventually save mountaineers, polar explorers, and accident victims decades later. The industrial legacy, too, endured. The women who wired those suits returned to civilian life with skills rare and valuable. Their precision assembly work became the seed of America's post-war electronics boom. They built radios, televisions, and early computers with the same attention to detail once given to saving bomber crews. A line could be drawn from the heated flight suit to the microcircuits of the modern world, both born from the discipline of mass-producing small, flawless components. Even in museums today, the surviving suits hold their own quiet authority. The National Museum of the United States Air Force in Dayton preserves several examples: cracked leather, aged wool, and wires still faintly coiled beneath the lining. They look unremarkable until one considers what they meant. Each was a personal fortress against an invisible enemy. Each represented a victory not of aggression but of protection, proof that compassion could be engineered. The men who wore them never forgot. Letters from veterans preserved in archives tell the same story: gratitude. One radio operator wrote to General Electric in April 1945, saying, "You saved our hands. You saved our lives. You let us do our jobs instead of fighting the cold." The engineer's name was lost to history, but the effect of his work lived in every mission that returned safely. The statistics tell one story: frostbite casualties reduced by 94%, 10,000 hospital days saved per year, an economic return 800 times the investment. But the true measure lies in human terms. Each percentage point represented faces, voices, futures, men who came home whole. 25,000 severe frostbite injuries were prevented. 25,000 men who might have lost their fingers or feet kept them because a factory in Ohio found a way to spin heat into cloth. The legacy reached beyond the war itself. It redefined the meaning of readiness. Comfort became an element of strength. In every generation since, military planners have carried that lesson forward. Protect the soldier, preserve the mission. The modern military's heated gloves, vests, and boots are direct descendants of those wartime innovations. Though the materials have changed, carbon fiber replacing metal wire, microprocessors replacing rheostats, the principle remains the same: warmth equals endurance. Looking back across 8 decades, the technology seems simple. It used no rare metals, no advanced chemistry, only copper, nickel, silk, and faith in problem-solving. Yet from that simplicity came strategic power. The suits allowed airmen to fight not just the enemy, but the environment itself. They turned nature's cruelty into a conquered frontier. When historians search for the keys to Allied victory, they speak of production numbers, tactics, leadership, and code-breaking. Yet hidden beneath those grand themes are the humble inventions: oxygen regulators, better parachutes, flight instruments, survival kits, and above all, the heated suit. Victory in total war required not only great weapons, but small mercies. Each layer of comfort added a layer of endurance. Each solved inconvenience became an advantage. In the frozen skies over Germany, those small advantages multiplied until they became decisive. The men in their electrically heated suits could outlast fatigue, aim more precisely, and return to fight again. Technology had equalized the cruelty of altitude and turned cold from enemy to neutral condition. That quiet, practical triumph summed up the essence of America's wartime strength: coordination, innovation, and care for the individual as part of the system. By war's end, the heated suit stood as a symbol of applied compassion. It was proof that empathy could be mechanized, that protection could be mass-produced. It demonstrated that the might of a nation lay not only in its weapons, but in its willingness to value the comfort of its people. The irony remained unmistakable. The story began with the question: how did American pilots stay warm at 30,000 feet without heaters? The answer was that they carried the heaters with them, built into their clothing, powered by the same engines that lifted them into the sky. Their warmth came from wire and voltage, but also from a collective belief that human endurance was worth engineering for. In January 1944, a German fighter ace looked up at the bombers flying in perfect formation through the Arctic air. To him, they seemed untouchable, their gunners steady, their lines unbroken. He later wrote that the Americans fought like machines, tireless, organized, relentless. What he could not see was the hidden network of warmth inside each man's uniform, a silent current connecting pilot to factory, engineer to gunner, invention to survival. In that sense, every bomber that crossed the Rhine carried more than bombs. It carried a nation's philosophy, that progress meant using intelligence to shield its warriors from the worst the world could offer. Warmth became a weapon, not of destruction, but of endurance, a quiet force that kept men alive long enough to end the war that created it. When the crews finally came home, they left their suits behind in depots and museums. But the principle flew on. In every heated cockpit, every space capsule, every insulated jacket that guards a life against the cold. The simple network of resistance wire that glowed unseen beneath sheepskin remains one of the war's most enduring symbols of practical genius. And so, in the bitter winter sky over Europe, where temperatures fell to 60 below and the air itself could kill, the United States found victory not just through bombs or bullets, but through warmth, a current of electricity, of invention, and of compassion that kept its men alive at 30,000 feet.